In this video, we're going to take a look at specific heat capacity and how we can use specific heat capacity to figure out energy that is flowing into or out of a system. So let's start with specific heat capacity. This is a type of physical property. So it is a physical property, and its definition is that it's the energy required to raise the temperature of 1 gram of a substance by either 1 degree Celsius or 1 Kelvin. Really important to note here that the energy is represented by a value of joules or kilojoules, and we're going to be working in kilojoules more than we'll be working in joules. So there are tables of specific heat capacities for a variety of different types of elements, compounds, or other types of materials. This is just one such table here. And you can see, for example, something like aluminum has a specific heat capacity of 0.9. Liquid water has 4.18. Air has 1.02, and so on. So all of the values are very different from each other, and these are any values that really you could just look up in a data table. So we can use specific heat capacity to calculate the quantity of heat within a system, a reaction, really anything here, by using the equation Q equals mc delta T. So let's just define what all of these symbols mean. Q, to start with, is the quantity of heat transferred, and that's going to be in joules. M is our mass, and that's in grams. C is our specific heat capacity. Usually that's given in the units of joules per gram degree Celsius. And then finally, our delta T is our change in temperature, and that's taken as our final temperature minus our initial temperature. So depending on the change in temperature, if we have an exothermic or an endothermic reaction or system, you can have a Q that's negative in value, or you could have a Q that is positive in value. So let's see how this works with a specific example. In this example, we have 600 milliliters of water in an electric kettle, and we're heating it from 20 degrees Celsius to 85 degrees Celsius, and we want to know how much heat flows into the water. So let's use our Q equals mc delta T, and then we're trying to figure out Q, so we're going to plug in all of our other values. Now, the M is the mass of the water that we're heating up. Water has a density of 1. So 600 mils is the same as 600 grams. The specific heat capacity for water is 4.18. And then we're going to do our final temperature of 85 minus our initial temperature of 20. And if we do this calculation, and let's just put in all of the numbers here, we would end up with 163,176 joules. And it's a little bit nicer to express that in kilojoules, because then we can round off to 3 significant digits, giving us 163 kilojoules. So 163 kilojoules is how much heat is flowing into the water in order to heat it up from 20 degrees to 85 degrees Celsius. You should do a double check and make sure that makes sense in terms of the heat that's flowing in and the fact that this is an endothermic sort of system. So that's it for specific heat capacity and calculating the quantity of heat. That's it for this video. We'll see you in the next one.